Gravity.
There you go. Well, they bought us these iPads. In fact, that's my first iPad. We've actually had two. When COVID hit, we got this one. And then a couple years later, we had some extra money left over that we bought more of them. And I'm like, I already have these two, and I prefer the Windows tablet over the iPad. Because I prefer the Samsung stylus way more than I like the Apple stylus. This is the, not the bamboo, but it's a different, it doesn't actually have the battery.
They started moving off of those. They use what is it? Microsoft protocol that use the.
But this uses near field communication. So this is energizing when it gets close to the tablet.
Oh, so that's what it's doing.
So that's when it gets close, it's like, oh, there's energy, and it picks it up. It's way better. I'm sorry.
I think only the Samsung tablets are the ones that are supporting it right now, because everything else.
Nobody else, because they have an agreement with the company that made the original tablets with it. So Samsung's the only one that has these. So like my phone. Yeah, it's got that one right here, which also.
Oh, wait.
Pretty cool. All right. Anyway, so here it's really there we go. So here's the example of one where we construct the matrix. So we don't have to do three little matrices, and this is why I said you can use MATLAB to do this, right? Because all you really need to do. Come on. At any rate, we'll just leave it at that. We can construct this massive matrix, but really all we did is we stack our A's, our B's, and our C's. We constructed, this is that sub matrix here, so we have, this is looking for theta 2 that we have here. There's a typo on here, by the way. It should be theta dot. There's no dots on here, the initial final, so FYI, initial final, and that kind of stuff. So there's a mistake on, I think, hopefully it's fixed in your book. Go back and you'll see the original one, just reconstructed. So this becomes the stack of initial, final velocity. So again, that should be a theta dot 2, and then you move all the way down. So just FYI on, there's a typo. Hopefully it's been fixed in a newer edition, but if not, let me know. I can get to you. So again, we're looking for all of these coefficients. We know our times. We know our final for T1, our final segment for T2, our final segment for T3. We know our theta dots, our initial conditions, essentially, we have right here. We can compute our coefficients by simply taking the inverse of this M matrix times our thetas that we have, and that gives us our coefficients. Once we have that, then we can do everything. Big matrix, not going to work in your calculator. But it does work on your MATLAB. Why? You have a take-home part. Because you have the resources, okay? Let's just be honest.
Well, this is on the take-home?
You'll have something like this on your take-home, yeah. I told you, you're going to have to use MATLAB. You're going to compare an nth order, like a fifth order, constructed as a fifth order, compared to a blended order. And you're going to compute the coefficients and compute the trajectories for each one. I'm just going to tell you right now, that's going to be in your final. Okay. So I'm going to give you, this is a good little example that you have right here. Here's the example for it. This is what's been bugging me. It won't let me do it. So this is going to be a 5-3-5. You see where 4-3 for me. So you have this guy right here, and you can see the different acceleration. So what's kind of cool is it was given right here 2 seconds and 6 seconds. So there's 2 seconds of the ramp, the acceleration phase or the ramp phase, and then we have 4 seconds here for the travel phase. And we can see the accelerations for each one. Starting and ending acceleration, starting and ending velocity, starting and ending position. With the waypoint probably along the way. So here's each one of the segments that are defined for the durations 2, 4, and 2. So this is 2 seconds, and you just stack them on top. And these are the different displacements driven by the coefficients. Okay. So these are the computed coefficients based on the parameters of the initial conditions before. It's really just solving that linear equation, which is actually relatively trivial when things are considered. So that's a 4-3-4 Lotion profile. A 5-3-5 would go 5-3-5. So I'm going to give you some homework assignments on that to practice with it, and I'll give you the solutions for it as well. Okay? It's just practice. It's kind of like going, oh, okay. Give you a couple of maybe a third order, a fifth order. I don't know if there's a seventh order in the homework problems, and then do a couple of different things like this. Question, what's that? Huh?
You said that's a 5-3-5.
No, this is a 4-3-4. Yeah. Goes to the 4.
Oh, okay, yeah. Wait, starting at 0, no?
4-3-4.
Yeah, but still.
Fourth order polynomial. Not how many terms.
Okay, that's what you mean.
I know. I get being a digital guy, we start with 0 all the time, also, but I think of that as a 1. Yeah. So I'm always similar, like, no, it's a fourth, no, it's a fifth, no, it's a fourth. Yeah, fourth. So if I had a fifth order, I have an A5. So you get T5. Okay. Might be interesting to compare and contrast a 4-3-4 to a 5-3-5. Or, and I haven't asked this question, but maybe I'm going to ask this question because it's kind of cool. What does a 5-3-4 look like? So what I've given you guys is a MATLAB. Does each one of those segments. And you can simplify it from a fifth order to a fourth or to a third with that code that I will give you guys. So when you're doing your analysis, you can take the one segment, the one segment, and the one segment. You can either put them in one program, or you can manually stack them together. I don't really care. But I'm going to ask you guys to compute or to draw that graph. MATLAB would be your best approach. Just saying. Because this is informative, but this is everything. This is the entire description. Because now we can say, well, what's my max velocity? I can ask you the question, what's my max acceleration for the fifth order compared to a third order compared to a 5-3-5 or a 5-3-4? Right? Because that's the question. And the other question is, based on the Lagrange analysis that we're not going to make you do because I'm not going to be that mean. I'm not going to give you a Lagrange problem outside of the example homework I asked you to do. Because otherwise it's just, what's the, although it could be a third, I think I told you that third joint, that third arm could be a possibility, right? Yeah. Did I give you, oh, that was the Jacobian, my mistake. So you have to understand Lagrange, the concepts and the theories of Lagrange. You will have a theoretical question of Lagrange on your exam. I'm not going to make you compute the Lagrange because it's really pretty much a turn the crank. Okay. Outside of figuring out did you have the rotations here and there. Your exam, you will need to be doing transforms in your exam. I'm not going to dwell on it like we did on the midterm, but you have to understand it because we're going to start with an arm. Here's your arm.
You got
to go through the steps all along the line and do the analysis and simulation. But the simulation might be an arm you already have. I haven't written the exam yet, so. Okay.
When's the exam due?
It'll be due
Friday
of finals week.
Okay.
It's graduation. Before
Wednesday, you guys are doing presentations.
Okay.
And that's Monday.
It's Monday.
Monday's presentations.
So what's Wednesday?
Thursday,
Nothing.
we're done.
Nothing.
Okay, so just don't come in?
No, whatever you got on finals, just for Wednesday.
No, but like, cause I saw we only had one, I don't know if it was for lab or lecture, but I saw time slot for us on Wednesday. I don't know, that's why I was asking if you were doing it.
I'm not sure about that, no.
No?
Friday, we have, this Friday, in 2 days,
Yeah.
we have the competition, 3 to when we finish.
Wait, 3?
Is it
4, I'm sorry, 4.
4, okay.
4 to when we finish. I will probably be here around 3 to start setting up.
Alright.
5:23, unless it's not available, in which case I have to find them. I was gonna bring pizza, but it's all greasy, no, I'm just gonna bring some cookies and fruit or drinks and call it a day. Yeah,
5:23, not our,
not 4:35.
Gotcha.
4:35 has a class on Friday afternoon.
Gotcha.
5:23 is open, then check with Stacy. I think 5:23 is a better room anyway, so.
Yeah, the big room?
Yeah.
Okay.
That's the one we normally go to, right?
No, it's the one above it on the far end.
You'll send us.
Top of 5, go down that corridor, go to the very end, make a right, not the corner, it's the one just before. It says 5:23 above.
Okay, I was gonna say, send me the room number, I won't.
5:23. I'm telling you right now, you're a college graduate almost.
It's hard to remember 5:23 though.
5, because 5 minus 2 is 3, I don't know what to tell you.
That's pretty, yeah, that's.
All right, so this is robotics in a nutshell. We've done the introduction to robotics this entire semester, and we're finishing, this is where we got to. The very beginning, as I said before, we talked about controlling velocities, accelerations, we talked about controls, controlling those motions. And that's where the range is, as I said a couple moments before. Does this all make sense? You understand the big picture, yes? If you haven't read this chapter, this is as far as we're going in the chapter. There are a few other items you can talk, you can read, but at the end of the day, it's really the stuff we've already talked about. Like, well, what do you know? It's the Jacobian. It's the differential motion. That's what's defining the velocity, the joint velocities from that end effect. So there's that. You can do a small sub-segment, but I'm not really doing that. This is a fun read, so definitely read chapter 7. Okay. And this is simple stuff that's right here, coming right out of the stuff we've already done. And then there's this example, but that example I'm not a big fan of. So I'm going to give you the homework problems with the solutions, but there you go. There's the chapter 7. What's up?
Will you have a video for us like you did with control plus?
No. No.
Professor, what's the Lagrange problem you said you assigned?
There's a homework or an example I told you to review.
Which one is that one?
I forgot.
Number 7.
Number 7, yeah, 5-7.
5-7? Oh,
Yeah.
6-7. It's chapter 6.
6-7?
It's lucky number 7. And what I said to do on that was to go through it step by step to explain all the homework is going to do. I said Friday, but I'm going to make it Friday of finals week.
Okay.
Does that work
So
for you all?
Professor, like, we're gonna include it in the homework you're gonna assign, right? This one.
What's that?
We're gonna include this,
I'm going to give you some chapter 7 homework to work on.
and we're gonna include this one too, in the homework?
Which one? That example?
The Lagrange problem?
There's a Lagrange, yeah, so that, I gave that to you guys 2-3 weeks ago.
Yeah, like, we're gonna include this problem
Yes.
in the homework.
Yes.
That's what I mean.
Yeah, so what
Okay.
I'm saying is, because I haven't given you guys the submission yet for it, because I said just hold on to it.
Mhm.
Submit the whole thing, instead of having like 3 different submissions, make it one submission. Put all your files together, something like that, and we call it a day.
Okay.
Monday, Friday?
I'll give you Friday of finals week.
Okay, perfect.
And was it example 6-7 or problem 6-7?
Example.
It's simple.
Yeah.
It's-
No, I'm.
The one in the
thank you,
explanation.
None of you actually go said, ooh, 6-7. Somebody did do that? Where do I throw it from? Yeah, so the example, you're just walking through, that was the quintessential Lagrange. You're walking through explaining what's going on. So I just, because I'm going to give you a theoretical question on the exam on Lagrange. I'm going to say, in theory, blah, 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 blah. I'm not going to make you a number crunch. Why? It's just a calculus number crunch at this point. Let's see, what else?
Do you know which problem numbers you're assigning for
For-
chapter 7?
Yeah, I have it written down in my office now. Yeah, so I was going to bring that with me, I just realized I didn't have it. So, but I'll give you, they're going to be typical, they're not going to be hard. And again, the MATLAB that I gave you, that I'm going to give you guys, literally can do almost all the problems. You just have to like break it up into segments or make the values smaller, but it will work for you, which is why I'm giving it to you guys. And I think seeing that helps a lot. And I just haven't done a blended MATLAB, I probably should, but I think it's a good exercise for you guys to do it. Having that base 5 fifth order, you can go from there, just delete and take away, and add to and cascade. Most of the time when students do that, they'll submit, for the exam, you'll need to submit all of your code. If you want to submit for your homework, the code that does it for you, it's a good time to practice it. That's kind of what I'm telling you. So on the homeworks that I give you guys, if you write the MATLAB codes for that, it's a good time to test out your MATLAB code. So then you can just literally go into the exam and go, blah, 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 done. Comment on it, because there's going to be analysis and comment, but you don't have to create the code from scratch. That's really what I'm telling you guys. So you can kind of like work ahead on your exam right now for that problem. Make sense? You're going to compare and contrast the high order poly to the blended poly, as you would expect. If you were writing the exam, that's what you would do too, right? Let's be honest. Okay, that's it. That's all we got.